one of the study features on your exam, whether it is Junior Cert or Leaving Cert, will be triangles. So therefore, we really need to know how to deal with them. The diagram below shows a triangle ABC, not to scale, meaning basically you can't measure it to get the appropriate values. The point D and E lie on AC. So we can see it here is AC, and that's where I have D. And on BC we have E, respectively. And angle CAB, so where you have that middle letter, that's where is your angle. So they are saying this is the right angle. And DEC, so E, where is E? Here. So this is the right angle. They are 90 degrees. The length of some of these sides are given in the diagram with X and Y belonging to R, meaning that they could be any number. And we can see that this length from D to C is 15, from D to E is 9, from A to B is Y, from B to E is X. Oh, look at that. There is that length and this length are the same. So both of them are X. Okay. First thing we have to do, we have to work out the value of X. So how do we deal with a triangle in our question? Well, we go to page 16 in our table. Where is page 16? Oh, there it is. Lost you for a moment. And let's look at our options here. So that page 16, let's just get it smaller. It gives us two options. Pythagoras or trigonometric ratio. Now, which one are we going to use and what angle are we actually considering? So we have the big triangle, isn't it, that we can consider. And then we have the other right angle. Now remember, this is only about a right angle triangle. And then we have second smaller triangle. So the big triangle A, B, C, and what we know about that, well, we don't have this measurement because we only have part. This one we don't really have, that's just Y, so not measurement. This one again, we don't have it. We only know that it's twice X, isn't it? It's X and X, so 2 of X. When I'm looking at smaller triangle, E, D, C, what do I know about this one? From D to E is 9. Oh, very good. From D to C is 15. Look at that, even better. And then from E to C is X. Right, so this triangle have quite a lot of information. So that's the one we're going to consider. So again, how do we make a choice? Which formula to use? Sorry, I'm just going to draw that triangle again here so that I can explain. So we have D, E, and C, that being the right angle, then 9, 15, and that's our X. Okay, so the choice is between Pythagoras and, like we said, trigonometric ratio. Pythagoras have in the formula letter C, A, and B. And as you can see it on this triangle on this triangle here, C, A, and B are all representing the side, the length of the side of the triangle. So Pythagoras involved 3 sides. When I'm looking at trigonometric ratio, again, it doesn't matter which ratio I consider. Each one of them have capital A, and capital A, we can see it in our drawing here, that is an angle. So trigonometric ratio, definitely an angle. And then we have small letters AC, BC, AB, and we know that small letters are the sides, so 2 sides. So what are we looking for? X. What is X? Is the length of the side. So we are putting question mark. We are saying we don't know. We are looking for it. What information do we have? So here I have 9. That is what? A side. So I'm saying have it, have it. Then I have another side here, 15. So I'm saying have it, don't have somewhere to tick. So I don't have enough information for trigonometric ratio. However, I have enough for Pythagoras. So now I know that I'm going to use Pythagoras. Well, I need to know what is C and A and B in my own triangle. When it comes to Pythagoras, the only reference angle we are having is the right angle. So as you can see, opposite the right angle, you're going to have side that will be letter C. So that's where we have the right angle, and opposite that, that's my C. Well, that means one of them is A and one of them is B. It doesn't matter which one is A, which one is B for Pythagoras, because we are adding those values. Okay, so let's replace the letters with numbers from our triangle. So C is 15. So we are saying 15, don't forget power of 2, equal A is what? 9. And that is as well taken to the power of 2 plus, and B is my x, and x is taken to the power of 2 as well. Now, where am I going with this calculation? Oh, let's move that for a minute. Where we are going with this calculation, we want to have x equal a number. So that 9 has to go to the other side and join the rest of the numbers. So this side of the equation, I have 15 to the power of 2. When I'm moving a number from one side of the equation to the other side, what happens? It changes the sign to the opposite. So in this case, positive will become negative. So minus 9 to the power of 2. And then I am therefore left with x to the power of 2. Now I want x, not x to the power of 2. How do we eliminate that power of 2? We take a square root of the other side. And now there it is. I have letter on its own, numbers on the other side. I put that in my calculator, I press equal, and I get that x is 12. Okay, perfect. Let's have a look at next part of this question. So part B is saying using similar triangles. What's that? Work out the value of y. So at the end of my calculation here, I'm going to tell them y equal a specific number. What are similar triangles? As the word is saying, they are similar. They are not the same. In some ways, they are the same, but in some ways, they are different. So let's just get our draw. Oh, we can get this drawing. Just give me a minute. I will get our drawing. Okay, so we have our drawing here. So similar. Now, when we talk about triangles, doesn't matter what kind of triangle. When I'm trying to describe it, what do I talk about? I'm saying that this length, this length, this length. So I'm talking about the lengths, isn't it? The sides. I can say that it's, I don't know, 9, 3, and I don't know, 7, for example. What is the other stuff I can talk about triangle? Well, I can say that this angle is 25, this angle is, I don't know, 40, and then whatever that one is, right? So those are the elements. I can only talk about the sides and the angles. So similar triangle, they are the same in angles. So angles are the same. What is similar, so not the same, but almost, is the sides. Okay. So first of all, I need to identify where my similar triangles are. So we already done that a little bit in the previous part, saying that, you know what, this big triangle, that's one of them. And then I have another triangle here, the smaller one, the green one. When we do similar triangles, when you're drawing them out, and you do have to draw them out separately, otherwise it's very easy to mix them up. Let's put measurements that we know so far. So big one is A, B, C. This is Y. X and X, we already know what X is. We just find out that that's 12. So 12 and 12, that will make it 24, isn't it? And then the other triangle. So this is the right angle. That's where I have E. So we put E here. The short side, D. So that's D. That's the short side. And then the long side, C. So that's C. So DC is 15. The short one is 9. And then EC is 12. So it is important to draw them the way you can compare corresponding side. Now, what do I mean by corresponding side? So you know what? Let's call those sides something we can identify very easy. So let's say that this side is short, and therefore this side is short, isn't it? It's just a small triangle. Then we can say that this side is long, and therefore this side is long. And then, and then we have a middle line, isn't it? That one that is neither short or long is the middle line. Okay, so how do we build a ratio? Because this is the idea with similar triangles, that corresponding sides are in the same ratio to each other. So what do I mean by corresponding sides are in the same ratio to each other? let's say that this y goes into this long one twice. It will go one and it will go second time. If that is true in big triangle, that will be true in the small triangle. That short one will go twice into the long one. So that's the idea that we are using. So one of the ways we can build that, for example, here we can say as this short side in big triangle relates to the long side in big triangle, so is the short side in small triangle, relating to the long side in small triangle. Yeah? So that is my triangle that is red. That's my triangle that is green. Okay, so that's one way of building it. There is another video where I'm talking a little bit more about other different ratios, but here let's leave it at that. So how do I solve fraction equal fraction? Well, one of the way we can cross multiply it, or in this case, since I want y on its own, not y divided by a number, how do I eliminate that number here at the bottom of the fraction, the denominator? When we have a division, we multiply. And we multiply both sides of the equation. So why do we multiply? Because 24 divided by 24 is 1, and 1 multiplied by y will be y. So on one side of the equation now I have y, and on the other side I have my numbers 9/15 multiplied by 24. So I can put that in my calculator, press equal, and I work out that the value of y is 14.4. Yeah? So again, like I'm saying, when it comes to similar triangle, we can build ratios in different way. Please make sure you have a look as well at the other video about that.